So we are already done with the theory part of sequence and series. So we are going to solve the questions that are given in class test of sequence and series in your module, right? So some of the questions we have already done, and I'm gonna solve class discussion page number 59, sequence and series chapter of your module, right? You have your module for the crash course of JEE Mains. Okay, so let's start. So question number 1. So the question is this: you have to find the sum of these are the multiplications, and these are the terms. You have to find the sum of all these terms, what it is going to be, right? So in order to do so, you have to find the nth term first, right? Nth term. So what will be the nth term? Observe the pattern. 1 cube plus 2 cube means sum of cubes of first two natural numbers. And for the nth term is going to be like this: 1 cube plus 2 cube plus and so on, n cube. And in the numerator it is 1 upon 2, 2 upon 2, 3 upon 2, like this. 2 is going to be constant, right? So 2, and in upper part it is n, and in the second part it is going to be n plus 1 divided by 2. So this is how you can calculate the nth part, nth term. So nth term is going to be n into n plus 1 divided by 4 upon 1 ka cube plus 2 ka cube plus and so on, n to the n ka cube. So you have to just, this is the nth term, right? So just let's simplify it. N into n plus 1 divided by 4 on this, you know it, right? So sum of cube of first n natural number is n into n plus 1 divided by 2 whole square. So this is going to be n into n plus 1 divided by 4 upon n into n plus 1 divided by square, whole square divided by 4. So 4 will cancel out with this, and the square will cancel out with this. So nth term is going to be 1 upon n into n plus 1. So you know that, right? So sum of first n number in any series is given by summation of nth term, right? So this can be written as summation of 1 upon n into n plus 1. I already told you that you have to split it like this: summation n plus 1 minus n to n into n plus 1, right? The pattern always, these questions are always asked in like this kind of scenario. So n plus 1 minus n, and now separate them. So after separation you are going to get it like this: 1 upon n and n plus 1, right? So just now start substituting the values of n. You know that, right? The value of n, you can say that it is starting from 1 and it is going till n, or you can take it as a r, and the value of r is going from 1 to n, right? We have to do this. So substitute the values. First you have to substitute the value of n as 1. So 1 upon 1 minus 1 upon 2, right? This is the summation. N equals to 1 and 1 plus 1 2 for n equals to 1. Now n is equals to 2. So 1 upon 2 plus, or it is 1 upon 2 plus 1 3 plus n equals to 3, and this is going to be like this, and so on till n times that. So what you can see here, if you take first two terms, then 1 upon 2 is cancelled out with this, means first term and last term is going to be remaining, right? So what will happen if you sum all these are cancelled out, and in last first and last term will remain. So the answer is going to be 1 minus 1 upon n plus 1. So n plus 1 minus 1 upon n plus 1. So the answer is 1 upon n plus 1, and n upon n plus 1. So the option is going to be B. Okay. next one. Now second question is, let an be the nth term of the GP of positive numbers and these, then you have to find the common ratios. So the question is like this: there's 100 terms and an be the GP. An is nth term of GP. So sum of a to n from n equals to 1 to 100, and it is going to be alpha. So what you can say, it is basically a2, a4, a6 and so on, a200. So the value of this is alpha, and similarly n equals to 1 to 100, a2n minus 1 is equals to beta. This is something like this: a1 plus a3 plus a5 plus a199 is equals to beta, right? So then the common ratio, we have to find the common ratio, and an is the nth term of a GP. So let's say the GP is like this: a1, a2 and so on, a200. Okay, with the common ratio r is going to be common ratio. In GP, when you take alternative terms, then what happens? Let's see. So ar square, ar cube and so on, ar to the power n minus 1. And if you are taking alternative terms, first, third, fifth and so on, so ar square, ar to the power 4, like this. So the common ratio is going to be, new common ratio is r square. If the common ratio of GP is r, then after taking it alternatively, the common ratio will become r square, right? So for this particular case, the common ratio is going to be r square, and for the same reason, here also the common ratio is going to be r square. So what we get here, alpha is equals to, first term is a2, right? So a2 is what? a2 is ar, and this is going to be ar cube, and this is going to be ar to the power 5 if you apply the general expressions. So how many terms will be there? It will be 100 terms, and the first term is going to be ar. So the formula of sum of first n terms is ar to the power n minus 1 upon r minus 1. So here the first term is ar, and r is r square, so the square to the power n minus 1. And what is n? N is 100. Total number of terms in it is 100. The first term is this, so r square is this upon r minus 1. So what is r? R is r square, so r square minus 1. And similarly for beta, the first term is a, so first term is a, third term means ar square, fifth term ar to the power 4. So this is going to be like this: a, the common ratio is r square, so r square to the power 100, because there is 100 terms, minus 1 upon again r square minus 1. So this is how you can do this, right? Now just divide these two. This is first, this is second. Divide equation 1 by 2. So alpha by beta is equals to, after division, what you can see, these terms are same. These will cancel out, and a will also cancel out with this. So the r is going to be, r will remain, and r will be the ratio of alpha and beta. That is the common ratio. So this is how you can do this. Okay. So the answer should be a. So the third question is the sum of infinity of the series. Okay, it is a APGP series, right? So it is an important question. So S is, let's say S is equals to 1 plus 2 upon 3 plus 6 upon 3 square plus 10 upon 3 to the power 3 plus and so on. So it is infinite GP, and you have to find the sum. So how will you know about it? So this is like this, 1 upon 3 to the power 0. So so s is going to be, these denominators are in GP, or you can say 1 upon 3 to the power 0 into 1, 2 into 1 upon 3, 6 into 1 upon 3 square. So this is how they form a GP, like this, 1 into 1 upon 3 to the power 0 plus 2 into 1 upon 3 plus 6 into 1 upon 3 square, and so on. So these are in GP, and these are 2, 6 and 10. So not this, let's exclude it for sometimes, and this term is going into GP, right? So what you can do in APGP series, always multiply it by R. So first of all, take it over here, take like this, s minus 1 is equals to 2 into 1 upon 3 plus 6 into 1 upon 3 square plus 10 into 1 upon 3 cube plus, and so on. So multiply it by R. Always in APGP series we multiply it by R. So if I multiply it with R, so it is going to be 1 upon 3 into s minus 1. So what it will be, so now if I multiply it with R, so if this is multiplied with 1 upon 3, this is going to be 2 into 1 upon 3 square, and this is, when this will be multiplied, it will become 6 into 1 upon 3 cube, and the next one, if I write, it will be going to be 14 upon 3 to the power 4, and this is going to be 10 into 1 upon 3 to the power 4, and this is how it will go on, right? So this is how you can do this. Now subtract this minus this, so s minus 1 minus 1 upon 3 times of s minus 1. So there is nothing to subtract it. One thing you have to notice, how I have written it, right? So please keep in mind, so like terms below like terms, like terms below like terms, like this. This will be easy way to solve this, or to avoid confusion basically. So 2 upon 3, now subtract these two, 6 minus 2, 4, so 4 into 1 upon 3 square. For this, 10 minus 6, 4, so 4 into 1 upon 3 cube. For 14 minus 10, 4 into 1 upon 3 to the power 4, and so on. This will go till infinity. Now take 4 as a common, so 2 upon 3, and after subtracting, it is going to be x minus 1 into 2 upon 3, and 2 upon 3 plus 4 as a common, 1 upon 3 square plus 1 upon 3 cube plus, and so on, right? So it is a GP of infinite sum. So what is the formula for that? Sum of infinite GP, a upon 1 minus r. So this is going to be 2 upon 3 plus 4 into sum of infinite GP. A is, what is A? A is 1 upon 3 square, right? And this is going to be 1 minus r. So what is r? R is 1 upon 3. So after simplification, it is going to be 2 upon 3 plus 4 into 3 minus 1, 2, I guess 1 upon 6. It's like this. 1 upon 3 square, 3 minus 1, 2, 2 upon 3, 3, yes, 4 upon 6, so 2, 3, and 2 upon 3 is 1 upon 3. So this is how you can do this, right? So s minus 1 into 2 upon 3 is 4 upon 3. S minus 1 into 2 upon 3 is equals to 4 upon 3. 3 will cancel out with 3, 2 2 ja 4. So s minus 1 is equals to 2, the value of s is 3, right? So this is how you can do this. So the option B is the answer, right? So this was the question number 3, and the answer is 3 also. Okay. So the next question is question number 4. The sum of infinite terms of the series is finite, then x belongs to. So you need to find the range of x basically. So x is given as x is less than pi by 2 but greater than equals to minus pi by 2, and the infinite g is this, cos x plus 2 upon 3 cos x sin square x plus 4 upon 9 cos x sin to the power 4x plus, and so on. So it is infinite GP. So in the infinite GP, what is the formula? A upon 1 minus r. So what is A? First term. So cos x upon 2 upon, and what is r? If you divide this by this is going to be 1 minus r, and what is r? This will cancel out with this, 2 upon 3 sine square x. Okay, so this is your so this is a finite GP, and the sum is going to be finite. So in order to means the sum to be finite, this value should not equals to 0. So this should be means 1 minus 2 upon 3 sine square x should not equals to 0, because if it is 0 then the whole term is going to be infinite, right? So what we can do, we can simply 2 upon 3 sine square x is equals to 1. So sine square x is equals to 3 upon 2. So sine x is equals to plus minus root 3 by root 2, like this. Okay, so so what we can do, see, x should belongs to, according to options, so x belongs to minus pi by 2 to pi by 2. So sine square x, if sine square x becomes 3 by 2, right? If sine x becomes 3 upon 2, or you can say square root of 3 by 2 plus minus square root of 3 by 2. In case of plus root 3 by 2 and minus 3 by 2, so we know that the values are given from minus pi by 2 to pi by 2, and like all these values are lying in first quadrant. So what you can do, 3 upon 2, so let's look on the values. So 1 to minus 1. So first is saying that pi by 2 to minus pi by 2, like this. The values are given like this. Okay, so pi by 2 to minus pi by 2. So it is maximum to minimum. So it is possible in this range from here to here, it is possible the value of x to attain the value of plus minus 3 by 2. So option B can't be, so it should be eliminated. Now next here, so the values of x is, means option A, for option A, x belongs to minus pi by 3 to pi by 3. So what is the value of x at minus pi by 3? It is minus root 3 by 2, and for pi by 3 it is root 3 by 2, right? So is it possible to attain the value of minus 3 plus minus root 3 by 2 for this? So if I take plus 3 by 2, right? So root 3 by 2 and root 3 by root 2. Okay, root 3 by 2 and root 3 by means square root of 3 by 2 and root 3 divided by 2. Which one is smaller? This one is smaller. Okay, so root 3 is divided by root 3 is divided by root 2. This can be written as root 3 divided by root 2. So actually root 3 divided by root 2 is greater than this particular value. How? Because root 2 and 2, root 2 is smaller. So if root 2 is smaller, the overall value is greater. So in root 3 by 2 and this value is greater, but the value in option A, what happened is x belongs to minus pi by 3 and pi by 3. Right, x belongs to minus pi by 3 and pi by 3, but the value of x for which the sum is going to be infinite is out of bound, right? So let's say this is pi by 3 and this is minus pi by 3. Okay, so the value at this point is root 3 by 2 minus, and at this point it is plus root 3 by 2, right? So it is minus root 3 by 2 here and plus root 3 by 2 is here, but we want the value of root 3 by root 2. In positive, in plus case, root 3 by root 2. So you can also check it. Root 3 by 2 is actually greater than root 3 by 2, right? So the value of this is going to be somewhere here, right, like this. And minus root 3 by 2 is also coming somewhere here, and value of x is lying between this to this. So in this case it is not possible that value of x will become plus minus root 3 by 2. So as x is not possible to attain the value of plus minus root 3 by 2, it is not possible to get infinite value, right? The sum is going to be infinite, is not possible. It's option A. Hence the answer should be option A. Okay, I'm repeating again what it is. We have to go with options, because at x equals to plus minus root 3 by 2 you cannot get the values of x, right? You cannot determine it directly. So according to option number A, x if x belongs to this, is it possible to have infinite solution? So the question is like this: if this is this, the sum of infinite term of the series is finite. So in order the sum to be finite, the value of sin x should not equals to plus minus root 3 by 2, right? Now for option A, the value of x is such that the value always lying the sin x is always lying between plus root 3 by 2 to minus root 3 by 2. Okay, so in option A, the value of x is such that the value of sin x is from root 3 by 2 to minus root 3 by 2, or minus root 3 by 2 to plus root 3 by 2. But the sin x, the value which we want for it to be infinite is plus minus root 3 by 2, and this value will be out of range for this. Means for all values of x between these, plus minus root 3 by 2 is not possible. Okay, so in this range, this is not going to be infinite. It will always remain finite. So if you are not getting this, rewind the video and watch it again. Okay, so this is how you can do it. It is question number 4. This is for the question number 4. So the next question is question number 5. Let there be a GP whose first term is A. So question number 5 it is GP whose first term is going to be A, and the common ratio is R. A and H are the arithmetic mean. Okay, so A is arithmetic mean and the harmonic mean respectively of first n terms, right? So if A are the first n, the common ratio is R, so the total n terms will be AR square, and so on, AR to the power n. And A is going to be arithmetic mean AM, and what is arithmetic mean? Sum of all terms divided by total number of terms. And H is harmonic mean. So what is harmonic mean is, so for calculating harmonic mean, what you can do is you first take reciprocal of it, so it will become AP kind of, right? And then sum them and divide it by n. So what you can say is, if there is A, B, C, for just illustration purpose, if A, B, C are some terms and I have to find the harmonic mean, what I can do is I can just sum them by taking reciprocal of these terms and divide by 3, right? So it is going to be A plus B plus C divided by 3ABC, or I guess AB plus BC plus CA. And now again take reciprocal of it. This is how we calculate harmonic mean, right? So you may have remembered for AB, for 2 terms, the harmonic mean is like this: 1 upon A plus 1 upon B divided by 2. So it is going to be A plus B by 2AB. Now take the reciprocal of this, so 2AB upon A plus B. This is how harmonic mean work, right? So this is how you have to do for this also. Now reciprocal each them. So you can say that 1 upon H, harmonic mean means 1 upon H, and this is going to be 1 upon AR to the power n, sum divided by n, right? And then whatever we get, we have to reciprocal it. So first of all, let's simplify this. This is sum of first n terms of an AP, so it is going to be r to the power n minus 1 upon r minus 1, and here it is going to be n. And for this case, by reciprocaling each term of geometric series basically, the resulting series is also in GP. So what you can do is, you can just sum them. The first term is 1 upon a. You will find that the common ratio is 1 upon r. So 1 upon r to the power n minus 1 upon 1 minus r minus 1. And this whole thing is divided by n. So like this. Okay. Just for simplification purpose, what you can do is, you can just simplify them. So I am directly writing it. You can do this by yourself. You just simplify this, right? So I am writing it directly. So it is going to be 1 minus r upon n upon r. This whole thing is divided by 1 minus r to the power n upon a r to the power n into 1 upon a. Right, so this is how you have to do. In reciprocal, it will work like this. And now, okay, so this is H, harmonic mean. And now what we have to do, we have to find the value of A into H. So we have to calculate A into H. Now just substitute the values. So A is this, A r to the power n minus 1 upon r minus 1 into n. And what is H? So H is this. So H is going to be 1 minus r into n, this part, and this will go, just simplify. It is very simple, you can do it. So this is going to be upward, so it is going to be a into r to the power n, a into r to the power n upon, and this will come down to the denominator 1 minus r to the power n. So this will cancel out with this. So how is it so? Take minus common from here and here. So they will become exactly same like this. So these two will cancel out also. So n will cancel out with this also. So what is remaining? So a square r to the power n divided by r. So r to the power n minus 1. So a square r to the power n minus 1 should be the answer. Right, so the option number A. Okay, this is how you can do this. Okay. So you should be careful about this, right? So harmonic mean, how do we find it? Just take the numbers, take the reciprocal of that particular numbers, sum them, divide by n, and then after take reciprocal of that. That is how we calculate harmonic mean for n numbers. Okay. So next is question number 6. So x, y, z are in GP. It is given there. Question number 6. So x, y, z are in GP, and we have to check log x square minus 1, log x z minus 1, and log z square to the power minus 1. What series they are following, whether they are in HP, GP or what, right? So we have to do this. So as x, y, z are in GP, what we know, y square is equals to x into z. So if you carefully observe them, so what is happening here? X square, z square, but there is no y, because xz is actually equals to y square. So just substitute the values, and using logarithm property, you know that log x to the power m can be written as m into log x. So the power get into multiplication. So this can be written as 2 log x to the whole power minus 1, right? And this is going to be 2 log y to the power minus 1, because xz is equals to y square, and y square can be written as 2 log y, and this can be written 2 log z to the power minus 1. If x is equals to a, then y is equals to ar, then z is equals to ar square y, because x, y, z are in GP. Let's substitute the values. So 2 log a minus 1, and 2 log AR to the power minus 1. 2 log AR square minus 1. So how can I write it? 2 log A, and this is going to be 2 log A plus 2 log R, and 2 log A plus 4 log AR. AR square log AR, R, just R to the power minus 1. Okay, so this is the very simple logarithm property. Log m into n can be written as log m plus log n. Now 2 log A to the power minus 1, these all are carrying a power of minus 1, right? So 2 log A is like this, and 2 log AR, so this can be written as, by using this property, log A plus log R, and 2 is multiplying out from the outside, so it is going to be 2 log A plus 2 log R. This is 2 log A plus 4 log R. How? Log A plus, this can be written as log A plus log R square into 2, and R square will come in the multiplication, and this 2 will make it 4, right? So this is how. Now if we do not consider the powers, so what it is? It is 2 log A plus 2 log R plus 4 log R. So this is basically in AP. If we do not consider minus 1 as a power, so they are in AP. And what minus 1 is doing? Minus 1 is just reciprocating them. Now, so these are in AP, these terms are in AP, and we are just reciprocating them. So reciprocal of AP is HP. Hence, this series are in HP. Right? Okay, so because these numbers are in AP, so how do we know that it is in AP? This is the first term, and this is the common difference. Now this term added with this make it, and this term added with the same term 2 log R will make it 4 log R. So these are in AP, and the reciprocal of AP is HP. So that is why it is in HP, and the answer is option number C. So this is how I can do it. This is question number 6. Now the next question number 7. So you just simplify them. I'm writing simplified form. So root 3 and root 75. It is root 75 basically. So root 75 can be written as 3 into 25, which is 5 root 3. So that is why it should be 5 root 3. And the next thing is 243, root 243. I guess it is going to be 81 into 3. So what is 81? 9. So 9 root 3. And I guess you will do it like this. It is going to be 4 root 3. Sorry, 13 root 3. Okay, 13 3 is 169 into 3. So 3 9 is 27, 7 2. Yes, it is. Right, so this is how it is going on. And the sum of this particular thing is 435 root 3. And it is supposed to calculate the value of n. How many terms are there? Okay, so what you can do is, it is in AP, so the point that you have to go to is to just write them in roots in simplified form. So now just apply summation formula. This is first term. Let's say there are n terms, so the sum is going to be n by 2, like 2a 2 root 3 plus n minus 1 into d. Into d, and what is d is root 3, 5 root 3. It is 4 root 3, right? Root 3 plus 4 root 3 is 5 root 3. So it is going to be 4 root 3, and this answer is equals to 435 root 3. So take root 3 as a common, and this is going to be cancel out. So n upon 2 plus 4n minus 4 is going to be 435. So it is going to be n, and 4n minus 2, it is going to be 2n minus 1 is 435. You just solve this, and you will get the value of n. I'm not solving it further. You can do it easily. You just get the value of n from here. And next is question number 8. if 25th term of an AP is this, so it is given that 25th term of an AP is 15. So what this implies, if the AP has first term as A and the common difference as D, so A25 will become A plus 24D. A plus 24D, right? So it is, yeah, it is 15. And the next part says that 15th term is 25. 15th term is 25. So they want this implies A plus 14D. 14D is 25. So we need to find the value of then the 40th term. So we need to find what will be the 40th term, right? So what is the 40th term? So you just subtract them. For calculating A14, you need to find the A and D. So by substitution method, elimination method, or any method, you can calculate the value of A and D and just get the value of A and D and substitute it over here. So I am just subtracting this. So after you subtract them, this will cancel out with this. 24 minus 10 is 14 is 10D. So 10D is equals to 15 minus 25 is minus 10. So this will cancel out and the value of D is minus 1. Just substitute it over here. So the value of it is 15 plus 24, because it is minus 24 will go there and it will become plus 24. So it is going to be 39. So A is this. So what is A40? A40 is A plus 39D. And what is A is 39. And what is 39D? 39 into minus 1. So it will become 0. So the answer should be 0. Yes, right? So this is how you can do it. So this one is the 8th. I guess this question is 9th. Okay, so this one is 9th. I'm gonna show you how to do the 8th. 3 number on the AP. There's some more 21 problems. So I can do this over here. So this is question number 8. So what you can do is 3 numbers are in arithmetic AP. Their sum is 21 and their product is this. So whenever there are 3 numbers or is given in AP, so how to let that 3 number is A minus D, A and A plus D. So let the number be A minus D, A and A plus D. Now sum them. After sum, it is saying that their sum is 21. So if you are adding them, so the 3 is equals to 21. So the value of A is 7, right? So A is going to be 7, and it is saying that their product is the product of first number and the third number. First number and third number is 45. So A minus D into A plus D. A minus D into A plus D is going, it is 45 according to the question. So 7 minus D into 7 plus D is going to be 45. So it is going to be 7 square, which is 49. 49 minus D square is 45. So D square is equals to 4. So the D is plus minus 2. So this is how you can get the value of D, right? So it is saying that then the product of these 3 numbers are. So just substitute the value over here. So it doesn't mean what you substitute. The value of D equals to 2 and minus 2 will result in the same 3 numbers. So if you substitute D equals to 2, 7 minus 2, 5, 5, 7, 9. You just multiply them, 35 into 9, whatever it is, the answer will be, right? So this is how you can do it. This is question number 8, 9. Okay.